Hello, Uggies Worldwide. I'm Dave Kassler, amateur radio callsign KE0OG, here with another episode of Ask Dave. Today we're going to talk about a very interesting device, one that's been around for, over 10 years now. This is called the SignaLink USB. And it's very common. It's used frequently for digital modes to connect the computer to the radio. It's more than just an interface device. It's much more. So it's a sound card in a box. It's a sound card made for amateur radio specifically, to look at that. But first, what I want to do is talk a little bit about what a sound card is. Let's pick purple here. Okay, so in the old PC computers, this started for PCs because IBM made a very interesting and unusual decision when it first started out with PCs, and that was to make the interface open, unlike Apple, which did not. And the PC had what were called expansion slots in it, where you could put aftermarket cards. And people came out with cards for everything. Oh, it was amazing. But one card that was of great interest was what's called a sound card. And it was a separate computer card, and it would plug into the bus on the PC. And if you had the right programming, if you had the right software in the computer, usually provided by the sound card maker, Sound Blaster was one of the big early ones. This sound card that went in here had the ability to turn coded instructions into waveforms. Now, at the time, it was really a stretch of the state of the art. I mean, we're talking, let's see, 80s, 90s, 1990s. To produce a waveform on command in hardware was state of the art. And sound cards were expensive. They were over $100, and sometimes they were $200, and people competed over the number of bits in the sound card, which had to do with the number of binary digits that were taken into creating a waveform. Nowadays, they can do this with video too, and they call the cards graphic cards. The graphic card is still usually a separate card, and I'm thinking like cards that contain NVIDIA graphics chips and so on. Those are very often still separate cards, although every motherboard has one, a rudimentary one on the motherboard. Well, the sound card grew so popular that the PC vendors, and there were a lot of different vendors of PCs, decided to move the sound card electronics because the chipsets for these kept getting smaller and smaller, 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 smaller. It used to be a big card, then it got to be a half card, then it got to be a quarter card, and finally the makers moved the sound card onto the motherboard. So here's your PC, and it's got a motherboard usually over here, and a little section of the motherboard was the quote sound card. Now obviously it was no longer a card. It's part of the motherboard. They could call it sound chips, they could call it a sound section, audio section, whatever you wanted to call it, but the name sound card stuck. And this, to this day, is the way you buy a PC. There is a sound card equivalent on the motherboard. Now, the question becomes, must you have just one sound card in a computer? And the answer is no. There's no good reason for that. And that turned out to be a good thing. I'll tell you why. Because back in ancient times, when people wanted to do digital with radios, they would just take the output of the sound card. There's often on a sound card with something called line in and line out, or sometimes just speaker and microphone. But you would hook the output with a cable directly to the radio's input in the microphone jack. And then you'd take the earphone jack or the speaker jack and connect that around to the line in. And that would work really well. And we could work some of the early digital modes that were available, the first of which that really caught on was PSK31. And you'd put amateur radio software in your computer, and it would create the appropriate tones to be transmitted. Now, there's something interesting to note, of course. Quality sound cards will go up to 20 kilohertz or so audio, which is way above what I can hear. At my age, I can hear up to about 8K. And they'd go way down, 10 hertz or something like that, for reasons of fidelity, very high fidelity. And the thing is, though, on amateur radio, the highest frequency of interest is 3 kilohertz, and usually starts around 300 hertz. The sound card modes were made to use this because this is the equivalent of an SSB channel. Your SSB transmission is approximately 3 kilohertz wide, 2.7 kilohertz wide. So all of this is wasted. All that extra stuff up there, there's no need to make anything that's that high. Now, a problem that people ran into, of course, was that Windows liked to make its own sounds. The beeps and boops and stuff like that. And unfortunately, that would go out, line out, and go out onto the air sometimes. And that was a full signal, and it would completely fill this bandwidth. Whereas a PSK31, it had about a 35 to 40 hertz bandwidth. And you would end up, when you put out those tones, you would obliterate the entire channel. So the idea came, well, what about a second sound card? You can put a second sound card in here. Windows is capable of addressing many sound cards. So you can have a sound card dedicated to Windows sounds, which will play through the PC speaker, and then another sound card dedicated to ham radio that will do this without interference. And then that way you don't hear the tones going in and out on the radio, which is kind of nice because those tones can be more than a little bit annoying. And then something that happened, though, was the more people did this, the more they realized that they needed to have some sort of isolation between here and here on both of these, because you'd get ground loops, and with ground loops comes hum. The 60 cycle hum. And that hum would be a real problem both in and out. And the hum was because the ground of this was connected to the ground of this through these, and you'd end up with a ground loop, and a lot of people weren't really grounding their radios at that point, and there was no talk back then of bonding the grounding to the other side and so on, like there is today. The most common way to do this, you could do it with opto-isolators, but what people did was little transformers. You could get at Radio Shack a little 600 ohm to 600 ohm audio isolation transformer for $2 or $3, and they're little tiny little things. And that's what a lot of people did. And this is the way I started out. I just had the one sound card, so I had to turn off all the Windows sounds. Now, somebody came up with the idea about the time these people did, SignaLink USB. If you look very carefully at what it says there, it is an integrated USB sound card. So what this thing does is you've got your computer here, And instead of plugging into the motherboard, it plugs into a USB jack. And then it plugs into this device, which is the SignaLink USB. And the sound card sits here. I'll just call sound card, okay? So the sound card sits here. There's no particular reason that it has to be attached to the motherboard directly. As long as the computer can control it, which it can do over USB, but not RS-232. USB sound card in here, and then this thing provided the isolation in terms of the transformers, okay, and it had some level controls. Just put some knobs there, and it could derive push to talk from the sound, you know, like a box or something, or it could take a switching command from the software, and it had an output for push to talk. Didn't mention that much before. You had to derive away for push to talk. So that was what was in this. And then they came up with a very interesting idea, which has since been duplicated a lot, and that is they have a single output connector on the back called radio that happens to be an RJ45. And so you put an RJ45 into it, and then they sell a cable that matches the input to your radio. This happens to match my Ten-Tec, okay, for digital input. And then inside are some jumpers that you can set for your particular radio. And it's still sold that way. You get the sound card, and then you get the connector, and the connector plugs into your radio, whatever it is. And then you tell your computer, and this is important, you've got to tell your computer what sound card to use. Now, as soon as you plug this into the USB, the computer discovers it and notes that it's a sound card and gives it a number. And gives it a name. It's USB audio codec. USB audio codec. Coder. Decoder. So this is what you will see. Now, different manufacturers may come up a little bit differently, but this is the one you want to find. It'll often have a number, maybe in parentheses or something, but this is what you want to point your digital software at so that it gets the right sound card. The biggest single problem with getting digital to work is getting it to recognize the correct sound card. The next biggest problem is getting it set up for push to talk. Now, this thing, you can either, the computer can tell it through the USB push to talk, or it will actually derive it from the audio. When there is audio present, it'll push to talk. And when otherwise, it'll be in receive. Now, so this is sort of the third generation right here. Nowadays, a lot of radios, here's your computer, and here's your radio, and you connect this to this with USB into here, and the sound card is in the radio. This is the case for the ICOM 7300, which is our reference station. And a lot of radios these days have the same thing. Now, it's interesting, it shows up in the computer as two different connections. One for the sound card and one for radio control. For things like changing frequency, changing modes, bands, all that sort of stuff you can do through that too. But one of those two is the sound card for the radio. And then your computer has to recognize the correct one. And these levels that are otherwise shown here as buttons, those levels are set from the front panel. You know, the volume going that way, the volume coming back in, and so on, are set via the front panel. So I thought what we'd do, just for fun, since there are a lot of radios out there that do not have sound cards in them, a lot of radios out there. This can be set up to work with any radio. By any radio, I mean any radio. You can get from them for about $15 a cable, or you can make your own if you're good at making these kinds of cables, and just wire the correct part to the microphone, the other part to the speaker, and the other part to push to talk. You could use this with a G90, or you could use it with a BITX, micro BITX. You could use it with a QRP rig that's a single sideband rig. This is a single sideband. It needs a single sideband transceiver to go with it. And it looks pretty cool. So let's look the thing over. We've got, it's a little box. It's not very big. Okay. And it's got the controls, power. Now, where's the power? I see speaker, auxiliary, radio, monitor, and USB. That's the power right there. It draws its power from the USB. So you don't have to have a separate power source for it. Nor do you need to use a monitor unless you're troubleshooting. Auxiliary would be an auxiliary input. Speaker would be a speaker so that you can hear what's going on. I've never used any of those except just the radio itself, okay? Now the jumpers are inside. Now they give you the Allen wrench that goes to these back here. And you take those screws out and you can adjust things. Now, why do I have the Allen wrench there? What do you think? Because if I separate this from the USB, it will never be found again. So we're going to take this tape off. It's just ordinary cellophane packing tape. And we're going to take off these screws at the back. And this will take a moment, so bear with me. Okay, now the whole thing comes off. Now, this panel is held on by the knobs. That's okay, because what we want to get at in here are the jumpers. And the jumpers, you just use these little wires and you push them down in to the correct places. Now, as it turns out, the Ten-Tec, I had an earlier Ten-Tec Jupiter, and they had the wrong resistor in the audio board for the audio coming in from the digital. So I had to I put a little voltage divider in there that you can see that's made with these resistors here, to get the signal way down to something that it would accommodate. There's not much else to it. Here's the audio isolation transformers right here. Okay. And just rev B, let's see if there's a date on it anywhere. SignaLink USB, Tigertronics, a relay for push to talk. There's your main sound card stuff. Nothing on the back. It's very, very simple inside. And you set these once. Like I said, I set them over 20 years ago. And now if I were going to use a different radio, I'd set these jumpers different and take that voltage divider out of there. The voltage divider is strictly there to get the levels down to something that the Ten-Tec Jupiter could deal with. Took a lot of experimentation, but I got it right. Okay, and the case itself is a piece of aluminum tubing. Now note what's there. Those are the extra jumper wires that came with it. There's 1, 2, 3 in here, and then there's 1, 2, 3 in here. So it comes with 6 jumper wires, and you can get the thing in any kind of shape that you want. Now this thing just fits into the slots here. Okay, goes into there. So we'll just put these screws on here. Okay, I think you can trust me to put those screws on. That gives you just a little bit of an overview of the evolution of the sound card and how it moved from being a plug-in device on a PC, an 80s era or 90s era PC, to becoming part of the motherboard on every PC, which is true to this day, to the point where you could get extra sound cards and plug them in so that you could have, you know, this sound for your game and so on. To the point where they made external sound cards, which, by the way, are really inexpensive. I had a problem with my last laptop that I actually wore out the headphone jack on it. So I thought, well, you know, I could take this thing in and have it repaired for 50 bucks or so to get a new jack put in there. Or I could get another sound card. There it is, right there. That is a sound card. And there are your jacks for your microphone here and your speaker or earphones here. And you know how much that cost on Amazon? That was $7. $7 for that. Okay, now you could add to this if you want. Add the isolation transformers, okay. You're going to have to put in some sort of a circuit to create push-to-talk. And radios computers no longer have the RS-232 output. So that becomes a little bit more of a problem getting push-to-talk. And that's where something like this comes into play, because it develops the push-to-talk from the sound right here. Like I said, this is made very specifically for ham radio. So that gives you a little bit of an idea of how we migrated from sound cards on cards to taking the equivalent functionality and putting it on a motherboard and still calling it a sound card, to the ability to add an extra sound card, to the ability to move the sound card off board using USB, to the modern technique of putting the sound card right in the radio. A lot of people still have radios that don't have sound cards in them, and that is where something like the SignaLink USB, again, it's a 20-year-old device, but this thing right here acts as an external sound card, level setting, and creates push-to-talk. All of that right there, and has a flexible interface that can go with any radio. And so you can plug it in regardless of what your plug type is on the back of the radio for digital. You can do that. You can get that cable from them and then set the jumpers in. So that's just a little something to see what a sound card can be used for, how it's used in the shack. And I hope you found that interesting. Please do subscribe. And please also check like, and if you would also go to dcastler.com/support for various ways that you can help fund this channel. And until we next meet, 73.